All right, we're going to get ready to look at another example of finding those independent and dependent variables. So I'll go ahead and write I for independent variable and D for dependent variable. It says, the faster Ron walks, the quicker he gets home. So what that's saying is we want to say to ourselves, which one depends on the other? Well, if I think about it this way, the time to get home, it depends on how fast he's walking. So his time getting home would be the dependent. Time to get home would be dependent on his pace or how fast he's walking. What we're going to talk about next is a function rule. And a function rule is an algebraic, if this says expression, it really should be an equation. Let's go ahead and change that. An equation has an equal sign in it, and we're going to use equal signs when we're writing that function rule. Function notation looks like this. So we have y, the dependent variable, is means equal. A function of is the f part, the independent variable, which is x. So we're always going to remember that y is the same thing as f of x. Y is always the same as f of x. So sometimes we'll see y equals 5x, and sometimes we'll see this f of x equals 5x. And it again is read as f of x is 5 times x. So we're going to do a few more where we define those independent and dependent variables. This time we're going to write the rule in function notation. So what I have here is I have a lawyer's fee is $200 per hour for services. So that means if you go see the lawyer for an hour, it costs $200. If you go see the lawyer for 2 hours, it costs $400. If you go see her for 3 hours, it's $600. So what we're doing is we are multiplying the number of hours times 200. That would give us our total amount. So our hours would be the independent variable, and the total cost, the dependent, because the cost depends on the number of hours we see the lawyer. Now to put this in function notation, we want to have t of something. The something is whatever variable you're using on the other side, which is h. So the total cost of the hours that we see the lawyer is equal to 200 times each of the hours that we see them. The next thing we're going to talk about doing is evaluating functions. So we're going to plug in the given input values and we're going to solve those. So what we have here is we're going to find f of x when x is 7 first and then when it's negative 4. So I'm going to write down the function f of x is equal to 3x plus 2. This is really pretty simple. We're going to plug in 7 for x. So we're going to say f of 7 is equal to, every time we see an x, we're going to plug in 7. 3, we're going to plug in 7 because there's our x. It says 3 times 7 plus 2. Now we're going to go ahead and solve for f of 7. F of 7 then ends up being order of operations. We need to do 3 times 7, which is 21. Then we put plus 2, and then so we get 23 for our function value, f of 7. The next one we're also going to plug in is the negative 4. So I'm going to plug in negative 4 for all my x values. I should have rewritten f of x equals 3x plus 2 so you guys can see where I'm getting this. So 3 times negative 4 plus 2. Order of operations says multiply first, so I get negative 12 plus 2. Negative 12 plus 2 is negative 10. So my function value at negative 4 is negative 10. We've got one more example we're going to try to squeeze in here, and that is this one. So I'll probably be able to do it for one of the two numbers. So if I look, h of r is equal to 1/3 r plus 2. Let's go ahead and plug in our 600 for our r's. So h of 600 is equal to 1/3 times 600 plus 2. 1/3 of 600 is 200 plus 2. So h of 600 is equal to 202. Now, if you guys would like to try this on your own, which I suggest you do get negative 2 as your answer.